So you want to use completing the square when you have a polynomial that is not easily factored. For example, x squared plus 6x plus 2, and it will be set equal to 0. So step 1, move the constant or the c term to the other side. So remember, ax squared plus bx plus c. All right, and that's set equal to 0, or we're going to move this over here and it becomes a negative c. So move the constant term. So in our example, I'll rewrite it. X squared plus 6x plus 2 equals 0. Subtract the 2 over, and we get x squared plus 6x. I'm leaving some space for our new term that we're going to add in there, equals negative 2. Next, step 2, take half of b and square it. So take b over 2, half of b, and square it, and add to both sides. In this case, my b was equal to 6. So that means b over 2 squared is going to equal 6. Oh my gosh, my 6's and b's look so similar. All right, so this is supposed to be a, let's see, 6 over 2 squared, which equals 3 squared, which equals 9. So I'm going to take this 9 and I'm going to add it to both sides. So this 9. And here I'm going to put plus 9 and plus 9. And so I get a new polynomial, x squared plus 6x plus 9 on the left equals, and I can go ahead and combine these two like terms, and I get a positive 7. Here comes the magic. X squared plus 6x plus 9 is in fact a perfect square trinomial. And so as we've learned, the generic form for a perfect square trinomial will be x in this case there's two plus signs, so it'll be x plus b over 2 quantity squared. So for us that will become x plus, and we did b over 2 earlier, b over 2 is equal to 6 over 2, which equals 3. So we get x plus 3 quantity squared. And that makes sense. That's our perfect square trinomial. And then we deal with the 7 on the right. We're going to subtract 7 to both sides, and we get x plus 3 quantity squared minus 7 equals 0. And that would be our completed form for completing the square. So that is our final step. Maybe you'll throw an f of x in front of it or a y. But we have rewritten our function in terms of using completing the square. And what's great is that this is also the vertex form. So x plus 3 squared, that's not a great 3, minus 7. And we can quickly find the vertex. It's negative 3, comma, negative 7. I take the opposite of that, positive 3. All right. So that was example 1 when we have a plus sign for both of them. We can look at another example here real quick. I'm just going to keep breezing through it. You can pause the video if you need to. So let's do x squared plus 2x minus 7. So no. Okay. Just want to make sure I wasn't doing the same one. All right, so equals 0. Well, let's complete the square. So step 1, I'm going to add the 7 to both sides. This time I'm just going to do the work. I'm not going to write out what we do for each step in terms of direction. So x squared plus 2x. I'm going to leave some space, equals 7. Now I take half of b. So half of b is, so b was 2. So b over 2 equals 2 over 2. And that means b over 2 squared is going to equal 2 over 2 squared. And 2 divided by 2 is 1, so 1 squared. And that equals 1. So now I'm going to, it's a positive 1, so I'm going to add 1. It's always going to be a positive number, actually. I'm going to add 1 to both sides. And I get x squared plus 2x plus 1 equals 8. Okay, so that was step 2. Now I'm going to go ahead and complete this perfect square trinomial. So we found out that our b over 2 is equal to 1. I should finish that. So we're going to have x plus 1 quantity squared. That's our perfect square trinomial, equals 8. And now we subtract the 8 over. And we get x plus 1 squared minus 8 equals 0. And there we go. We have rewritten our initial polynomial that was hard to factor in terms of something involving a perfect square, turning it into vertex form, which is later we will learn how we can find the roots from this, but we're not there yet. We're just doing the method. All right.